Alright, so we are back again, and this time we're going to move on to problem 15. So this one is a pretty fun one, I'd say, and I believe there was a similar one for the 12A, except this one is much easier in my opinion. Even though they look just as complicated, this one is a lot easier. So, thankfully, we're able to do this one with these. So let's draw out a cube, because all the numbers 2, or I'll just say the problem first, all the numbers 2, 3, 4, 5, 6, and 7 are assigned to the 6 faces of a cube, one number to each face. For each of the 8 vertices of the cube, a product of 3 numbers is computed, where the 3 numbers are the numbers assigned to the 3 faces that include that vertex. What is the greatest possible value of the sum of these 8 products? So there's 8 vertices in a cube, so let's just draw out a cube so we know what a vertex exactly is. So we have this, and this is a vertex, just all of these are all the vertices, and there's 8 of them. So now it claims that for each of the 8 vertices, a product of 3 numbers is computed, where the 3 numbers are the numbers assigned to the 3 faces that include that vertex. So, for example, we could have this top face equal to 2. We could have this side face equal to 3. And we could have this back face equal to 4. And the place where they all conjoin is this vertex. So this vertex will be 2 times 4 times 3. So this vertex will be assigned the number 24, which is 2 times 4 times 3. So now that we understand the problem, this is another maximizing, minimizing problem. There's a lot of maximizing and minimizing problems here. So we're going to try and solve this out. So first, it seems very complicated. What is the greatest possible value of the sum of these 8 products? So the best way to go is by creating equations, and equations help out a lot. So I'm going to try and make up a cleaner picture right over here. So what I like to do in order to make an equation is assign the variables. This is a bad cube, but whatever. I'll redraw it. So this is a very bad cube also, but I think you can understand the point. But sorry. So I think I have OCD because I'm being very bothered by my terrible cubes, so we're gonna have to redraw this. And yeah, this is good enough. So this is the cube, and we're trying to maximize this plus this plus this plus this plus this plus and so forth. I'm not going to say it. But best way is to really assign variables, and for maximizing or minimizing problems, it's very limited. So there's very little choices to what you can do. For maximizing a quadratic, you can maximize a quadratic using the vertex, or you can maximize anything by having all the rest equal to each other, or having all the products equal to each other. That's the best to explain it. So thankfully it's very limited, and it's likely that this is not going to be a quadratic. So we can assign this top variable, let's call it top, or no, let's call it x, and then call this bottom one y. So that means this vertices, this vertices, this vertices, and this vertices are all going to go towards x, and these bottom are going to go towards y. And it's going to make things a lot easier because all the rest are going to be the same, and you just replace x with y, and you're done. So we can just assign all these faces just A, B, C, and D. So we can let this be A, we can let this be B, let this be C, and then this right face be D. So in order to tackle this problem, we're going to create a formula and finding all these vertices. So the first one is going to be a times b times k, and it's going to give you this vertices. So a, b, k, or, oh really, I thought this was a k, sorry, x, a, b, x, plus, and we're going to do b times c times x, and it's going to give you this top vertices. So b, c, x, and so forth, c dx, and finally a dx. And then you're going to add the bottom, except it's literally the same thing, except it's just y, so that's why y is going to help you a lot. And then you just replace that with y, and it just makes a lot of things a lot easier. So we're trying to maximize this. Now, you might wonder, oh my goodness, this is such a pain to maximize. How am I going to maximize this? It's just a whole bunch of functions added to each other. Well, this is why we can easily see that we can factor out an x and a y, and it gives you these equal terms, which is why the x and y are great for differentiating it. So I'm going to factor out an x of this top part, and I'm just going to do a dot 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 plus, so this is just equal to that. And as you can see, this is kind of obvious because you just factor out the y and the x. And now by your factoring rules, you have x plus y times a plus bc plus cd plus ad. And this helps us a lot. We can try and identify this as a quadratic, but the best way to maximize this if these two factors are equal, or as equal as possible. That's the best way to maximize this. Or not necessarily these two are equal as possible, because you want to have like all the linear factors as equal as possible. So we can turn this, and thankfully we can simplify this even further. So we have b times a plus c plus d times c plus a. As you can see, these two are equal, and by more factoring rules, you have this. You can just go to this, and this just really simplifies it a lot. And just maximizing all three of these helps you just find the answer. So now we can pretty much find the answer. It's easy now to move on. So we know that we have the values from 2 to 7. So now, best way to maximize this is to make these all equal is if you add the bottom number plus the top number, and the second bottom number plus the second top, and the third top plus the third top. And I don't really know how to prove it, but it's just like, it's understandable. Like you could just tell. Sorry for my bad explanation, but yeah. So you have these three factors, and that's going to give you 9 cubed, because it's going to be 9 cubed. It's going to give you 729. And at last, D is your answer. And if we look at the last choice, 1680, and these are all the rest in the 3. So even if you were to guess 1680 and 729, you could try that out, but yeah. I mean, 1680 is a really large number, and it's way out of context, so I don't think that would be a good option. So D is the correct answer. And yeah.